Uh, my name is Roslan bin Talib, and the co-author is Mr. Professor Dr. Surveyor Muhammad Zailan Suleiman. We are from School of Housing, Building and Planning, University Science Malaysia, Pulau Pinang, Malaysia. This is a paper presented in the ICWSAUD 2020. The title of the paper is Identifying Building Defects in Malaysia, Why and Where It's Happened. Okay, so the first thing is on the abstract of the paper. You can refer to the paper that the papers talk about most of the property. Yeah, it's been dealing with the defects problem, whether it's defects occur to the outside or the inside of the building, but somehow the defects of the inside of the internal space is quite important because we spend more time inside of the building rather spend outside of the building. So we have done this qualitative survey, okay, and somehow we record back all the real projects defects from the real uh, uh, projects that happen. Yeah, the thing is now is that the components, the building components that we for the actual cases has been extracted from the real case studies within the 10 years period. I think around 2009 to 2019. It's about 10 years. The data will be presented in three main tables, and it shows as much as about 3,700 total number of defects gathered from the 4 SWC, Specialist Waterproofing Contractor, okay, located in the west coast of Malaysia. Okay, now it seems like we have separated 13 factors within this latent, okay, the unseen defects and the non-latent defects. This is the defects that you can see as shown in figure 1 below. The existence of the gap among the action is noticing the building defect is the main research objective, which is laid down within the research. This is some sort of graphic formulation, a flowchart that I developed after reading through some of the literature research, which is it shows the conceptual framework formulating a guideline. What I call it is one-stop defects data reference center, or in short OSDDRC. Okay, it started to the left, the first column there, from the I think it's about 11 or 13 factors there, variables, starting from the design detail to this structural up until the interior enclosure, as well as the sustainable issue or the plumbing, the fire safety, the building codes. Then if there is a defect fails, then is reported to this OSDDRC. Of there's no defects, is job well done. But somehow from this the database, defects database, we have to segregate between the latent or non-latent defects. But before we have that, there is a gap that we must identify how to prevent it, how to detect it, and how to refine it. Yeah. Okay. Now, this is also this sort of like a framework. Yeah, I call it a methodological framework in doing the buildings defects research. Yeah, after go through the literature research. Yeah, from readings from these constructions, managements, building defects. Buildings waterproofing journals and so on. I formulate this flow chart here, framework having three stages. First stages is the prelim stage, which is on the literature research. Second stage in the blue one is the data collection, this interview, this what we call the qualitative method, and the next one is the quantitative, and the third stage is on the report writing. Now, the third column is quite important of the stage where you identify problem from the research, you identify the gap. Then the stage 2, you collect the data, you test the defects. You can even test the defect, the technique, and the system. And then you do the interview from the experts in the field. Do the pilot test containing Likert scales questionnaire. Revising the questionnaire. And then start collecting the data and analyze it. And then use this statistic program to develop the analysis. And the last one is to do the writing. Okay, so it seems like this is a mixed method approach. So the study is first part here is more into the qualitative, as I mentioned before, for SWC within the 10 years period. Yeah. Okay, you can read through here. 2 in Klang Valley, the SWC, 2 in Northern State. Now, okay, now, this is the first of the schedule that I've done from this archive collection of the project, as I mentioned, within that 10 years from the 4 SWC. Approximately about 80% of these data come from the government or GLC projects, and there's roughly about 200 projects or 200 buildings involved, where the other 20% from the private companies projects, involving the defects from about another roughly about 50 buildings, involving of these building leakage defects, things like that. So from this, you can see from the first schedule here, there's two categories here, which is the latent defects and the non-latent, and it's ranged from the roof, the skyline, the wall, external wall, internal brick, a concrete or plastered wall, a door, the door and the window, the floor, and even the structure like the foundation or the vegetation and this rooftop, things like that, or from the soil movement, things like that. So the total of the one that we get from the data, from the projects, involving this kind of defects, where the latent is about 578 cases, which is unseen defects happening after handover or after the warranty period. The defects arise, and the non-latent defects about 477. This happened during construction, during handover, after the handover, things like that. It's all range of that, and it's total about 1055. Okay, now this, it seems like 1055 total number of defects, yeah, as I mentioned before, on the table 1. Okay, a total from the latent or non-latent, which is, I think, is quite excessive, yeah. Again, as I mentioned, the 7 separation type of building components with 39 of subcomponents, and a total of 53 defects of 318 defects from the roof category. Yeah, we're talking about the roof, which is among the most important uh, component of the buildings. Okay, the minimum total of defect found in this data is only 13 defects, 7 in latent, 6 from none, is from the below ground uh, undergrade water problem, defects problem. Yeah, so it seems like roof is most giving the most problem, whether it's concrete roof. From this data, it seems like it's the roof tile or concrete roof having the most problem. The roof tile, yeah, from the survey. Okay, now for the next table, yeah, we got here 13 categories of the roof and the wall building components, from the concrete flat roof, CFR, tile roof, metal roofing, skylight, and the wall is like the components are like internal wall, external, door, window, floor, and the substructure down there. And it's on how to minimizing this building defects, this building failure. Okay, how to minimize it. So we have like the 13 categories. Yeah. For example, the first one, or maybe I choose the highest one, which is 151. Avoid misguided application of waterproofing sealant or sealant material. So it seems like the waterproofing solution either on the wall or the flat roof, the CFR. Here, the CFR is the most problematic from the 151. It's for 34 of it. Okay, the rest is about the same average in the teens, 12, 17, 16, like the 17 on the external wall. The sealant materials maybe used is not correct, have a defect. But anyway, it got total about 1,274 identified defect from this about 250 buildings in total. Government, mostly of the government buildings. And most from the graph is we can see here most of the problem got into CFR again. There's a lot of problem in the concrete flat roof, and the next is these two here, which is the metal roofing, have a lot of defects, and the external wall is comes second after the concrete flat roof, aka CFR. Okay, this is the one that I just mentioned just now. Okay, just go to the next slide. Okay, now here we have quite extensive data, yeah, which is involving the exterior and the interior part of the building. Yeah, we have come up with the statistics, verification that what type of leaking is the most, what type of the leaking, peeling off or things like that. So you got here a range from leaking, crackling, moving, blistering, splitting, rusting, defects that making holes, sagging or shrunk, is a defective defects, expired sealant, loose until moisture or algae or mold problem. Okay, it's total about the total of the defects is about 1,500, and it's involved all with the exterior building components, for the exterior brick wall or exterior concrete wall, doors, windows, planter box, foundation, landscaping, roof, gutter, yeah. I think it's including this RWDP, as well as there's another category, number 2, which is on the wet areas, internal wet areas like the wudu, the shower, toilet, the kitchen, or the floor of the interior brick wall, the ceiling. It's also involved the fire protection, yeah. Okay, they got the fire protection, not many, only it lose 8 defects. 8 is collapsing, maybe the sprinklers not working, falling down and things like that. The leaf pit, and it's total about 1,300. So the interior part about 1,003. So the exterior about 1,005. So it's nearly about 2,800 defects formed from this extensive list. From here, what we got here is the most is on the gutter problem, which is 137 defect cases. Okay, the most for the exterior is the gutter, I think including RWDP. Well, in here we got 21 cases on the clogging of the gutter or downspout or RWDP. 21 of the clogging, I think is from the leaves. Maybe the leafy tree near the building, so with the wind bring the leaves and clog this gutter. As far as the interior, the most is with 104 cases of defects, is on the ceiling problem, where 23 of the ceiling is cracked. You can take a look of the schedule, the one that I developed, okay, and from the gathering of the information of the real project, 23 cases of cracking of the ceiling. So anyway, if we can categorize it in certain categories, 219 cases of the cracking problem, total, indoor and outdoor, exterior, interior. Most is 219, next is 116, both categorizing on the leaking. So leaking and cracking is the most problem from this data collection. Okay, data just mentioned from the table 3 just now, just explain it. Okay, you can refer it in the paper later. Cracking is most problem, as I mentioned before. It's interesting to note that one of the literature research, a good book from Mr. Cobalt, written in 2008, stated that 90% of the water intrusion occurred within the 1% of the total building surface or exterior surface. This 1% are all too frequently lead to building failures, even though it's just 1%. I mean, like if you have launched a rocket to the space, that 0.1% of the leakage may blow up the rocket, you know. This is what is the Cobalt interpretation. And even though this 1% will spoil the buildings, okay, it will give the bad impression of the. So from the conclusion, I think from the 3 tables selected for the papers, hold on. Sorry about that. It's quite anyway. This is quite extensive information that we had here on the components of the buildings and what type of defects happens from the 3 tables there, and why it happens. And I think my suggestion is that I think like JKR or PWD from the government may take a leading role in getting all the data, like producing this one-stop defects data reference center, get all this data collection on the defects, regardless it's latent or non-latent, external or internal, especially the internal one, so that all the construction industry players can refer to. I can like in a soft copy or in hard copy. So the mistakes of these construction defects it's not been repeating. It's been repeat and so on. So we can target a good quality buildings with 0 defects mission onwards, because we know that we have identified what's the problem, and the statistic shows that got quite a serious problem. I think it's a serious problem, from all the component of the building component, and where does this happen? You know where this happen, what component is always happens, and what is the factors, why this is happening, things like that. With that, I thank you everybody for listening to this presentation. Anything you can mail me or get contact to ask further if you're still interested in the topic. Thank you very much. Thank you.